Yesterday, we continued our analysis of acceleration in our Group B equations with one specific case involving acceleration, and that was gravity. We know that in the absence of any other forces other than just gravity, everything will accelerate downward at what rate? 9.81. We're going to make it negative 9.81 meters per second squared because it accelerates downward. The object, as I drop it, speeds up in the negative direction. But what about that object that I throw up into the air? What's the rate of acceleration or deceleration, as the case may be, for the rock that goes up into the air? Negative 9.81 meters per second squared again. Can you explain to me how it can be a negative 9.81 when the object is going downwards and going upwards? How can it be negative 9.81 in both cases? Yeah, it's still going to come back down eventually. Yes, it will. Louis? Good. So the one that's moving downwards is speeding up in the negative direction. The one that's going upwards is slowing down in the positive direction. Both of those give us a negative acceleration. Speed up in the negative direction, slow down in the positive direction. We get a negative acceleration in both cases. And in this case, neg 9.81 for both situations. Okay, all the equations that we learned within our Group B equations are valid here. Vf squared is equal to Vi squared plus 2AD. A is equal to delta V over delta T, and so on. They're all still valid, just the same as they have been for the past week. But now we have acceleration in every single one of those questions. That is involving gravity. A is neg 9.81. All right, we had 3 questions for homework last night on page 58. Pretty sure we're going to have to go over question 2 and 3 based on what I saw when I took a peek to see who had it done. Any issues with question number 1? Or are we good with that one? We're good? Okay. Question number 2. Having scored a touchdown, a football player spikes the ball in the end zone. If the ball was thrown down with an initial velocity of 2 meters per second from a height of 1.75 meters, determine how long it's in the air. What do we have given to us in this question? What do we have given to us here in this question? Give me one thing. Yep. VI is 2 meters per second. Let's make it negative. Why negative? Because it's thrown which way? It's thrown downward. We're always going to make up positive and down negative. Therefore, VI would be negative 2.0 meters per second. What else we got? What else we got? Derek? What is that? Okay, good. 1.75 meters. Is he right, by the way, guys? Close. He's close, but it's not perfect. How are we going to fix his tiniest of tiny little mistakes? We're going to make it negative because it's downwards, right? Its displacement is downwards. It ends up 1.75 meters below where it started. We're looking for time, right? How long it's in the air for. Is there anything else we have? Good. We have acceleration as neg 9.81. Look, if you look up here, the temptation is to say V is equal to delta D over delta T, isn't it? Is that not tempting to try? What's wrong with this? Why can't we do V equals delta D over delta T? Why can't we do that? Good. This is a group B problem. It's involving acceleration, not constant velocity. What this would actually get me, it would be a legitimate number that it got me, but it wouldn't be what I'm looking for. Okay? I could use this equation to get the average velocity if I knew what the time was. Okay? But I don't know what the time was. Okay? I have a velocity that's not the average velocity. It's the initial velocity. So you know what? Just don't even go there. Don't even go there in a group B problem. Let's get rid of that. Lewis said that A is negative 9.81 meters per second squared. Which of the group B equations do you want to try here? Looking for T. Oh, I think I know which one I want to try, and it looks kind of ugly a little bit too. Allie, which one do you want to try there? Keep in mind, unless you say V equals D over T, there's no wrong answer here. Yep. I know which one you mean there now. Okay. D is equal to VIT plus 1 half AT squared. That's the one that I would use too. But it's okay to pick another one. Sometimes somebody might have picked another one, solved for something that they weren't even looking for, and then used that in order to get what they were looking for. Lewis, question? No, you couldn't. Is the final velocity equals 0? No. That's a good question. That's a question I get a lot, actually. One that I got yesterday. I'm not sure if it was for this one or another one, but when you drop an object, the final velocity is not 0. Okay. Can I have a volunteer? Okay. So Haley lay down on the ground there. We pretended to drop the hole puncher. Of course, we weren't going to drop it on her, although she looked a little scared there when I threatened to drop it on her. We were never going to drop it on her. If we had, it would have hurt, right? It would have hurt because it's a heavy hole puncher, and we were going to, pretending at least, to drop it from a pretty high height. It would have hurt. But it would have hurt because it was moving when it hit the ground. When it hit her, it was moving. VF is not 0 there. When we're analyzing the fall, VF is something. Some velocity hurts. 0 velocity doesn't hurt. So VF would not be 0 there. Okay, it's a good question there, Lewis, but VF is not 0. All right. VI, oh boy. Oh boy, yeah, I don't want to use this equation. Lewis, this is the first email you sent me last night, right? Yeah. Who volunteered this equation? Who was it? Yeah, you know what? That was my first instinct as well, Allie. Absolutely my first instinct. Problem with that is that that's really difficult to rearrange. In fact, you got to use something called the quadratic equation to rearrange that. And a lot of you haven't even heard of the quadratic equation. Okay? So we're going to pick something different. What I'd like to do is maybe solve for something I'm not even looking for. Maybe that will help me solve for delta t using an easier equation, okay? So let's say, I don't know, I can't use A is equal to delta V over delta t because I don't know what VF is. Could I do this? VF squared is equal to VI squared plus 2AD and solve for VF? Could I do that? Sure. It's not what I'm looking for, but it might help me when I get it to solve for what I am looking for. VF is going to be equal to the square root of 2 squared plus 2 times negative 9.81 times negative 1.75. Hey, I got a quick question for you. Good question, too. Why did I drop the negative there for the 2? Why did I say 2 squared, not negative 2 squared? Because the initial velocity was 2 downwards, right? What did I need to plug in, Atlanta, right here? What variable do I need to plug in there? What does VI stand for? Good. Initial speed. What did I plug in? The initial speed. Okay. What did I have given to me? The initial, right. That's why I dropped the negative sign, because this is speed, not velocity. There is no direction with speed. Having said that, if you squared the negative, what would you get? You get a positive anyways, right? All right, let's see what we get when we do that. Let's say 2 squared. Let's add to that brackets 2 times neg 9.81 times neg 1.75. Now let's not forget to square root that. We end up getting 6.1915 meters per second. How many people, by just out of curiosity, did it that way? Any other question? Yeah. Okay, good question. Because we said it was speed here, how can we still use negative for the acceleration in the distance there? Well, because it's acceleration and displacement. Okay. part of this equation is vector-based, part of it's scalar-based, right? VI and VF, speed. A and D, acceleration and displacement, and they're vectors. So whenever you see that arrow over it, you've got to put direction in there. Whenever you don't see the arrow, you don't put direction. Even if, listen, part of this equation, need the direction, part of it you don't need the direction, it happens. Okay? Just because VI is a scalar doesn't mean we can drop the negative with a vector over here. Okay, does that make sense? So we got 6.19515 meters per second. How many people did it that way and got that answer? Anybody? No? Okay, fair enough. Now I think I want to use A is equal to delta V over delta T. I'm going to rearrange that to solve for T. We went through this yesterday, didn't we? What's the first rule of rearranging? What do you got to do first? Yep, get it on the top. T's not on the top. How do I get it on the top? Yeah, multiply it. So T becomes equal to, T times A is equal to delta V. Now, I got to get rid of the A, get rid of that by dividing. Delta V over A. Delta V, VF minus VI, 6.1915 minus negative 2 over negative 9.81. Is that right? Hey, why did I make that negative 2 instead of just 2? Stephanie? Oh, I think you caught it. I think she got it. Okay. Stephanie's my new favorite student, I think. Yep. Yes. Good observation, Stephanie. Good observation. The 2 should be negative because it's a downward velocity. And acceleration involves velocity, a vector. It should be negative 2. But the 6.1915 should be negative as well because it's downward as well. Now, right here, we just left it positive because we calculated speed and the equation gave me a positive value. But we know that it's down. So when we go to plug it into an equation as a velocity as opposed to a speed, we've got to make it negative. Very, very good. Okay, if that was ever a multiple choice question on a test, I guarantee you one of the options would be whatever you get when you forget to make 6.19 a negative value. Anybody else catch that and we're just kind of a little bit afraid to say? Sometimes we're thinking something and then we're just afraid to speak up in case we're wrong. Looks like you were it, Stephanie. Stephanie's the queen of physics today. We should have a little crown for somebody each day, whoever's the king or queen of physics. Stephanie's it today. Sorry, we don't have a crown for you though. Let's say negative 6.1915. I'm going to say plus 2, right? Do you see what I'm doing there? Plus 2. Subtract a negative 2. Divided by negative 9.81. 0.4273. .43 seconds. And lo and behold, that's what I got there. Did anybody else get this in a different way? Did anybody, just out of curiosity, try the quadratic equation? Did you get it? Let's take a look at number 3 right now. An elevator moving downward at 4 meters per second experiences an upward acceleration for 1 point. Wait a second. That doesn't make sense, does it? How can an elevator moving downward experience an upward acceleration? What do they mean by that? It's moving downward, but it experiences an upward acceleration. Don't you have to be moving upwards to experience an upward acceleration, Carrie? No. That would be a downward acceleration. Oh, I thought you had it. I thought you had it. You were so close to taking over Stephanie's role as my favorite student. Nope. It's moving downwards, but slowing down. Which way if something's moving downwards and you want it to slow down, which way do you have to push on it? up. And if it's moving downwards, but you want it to slow down, going downwards, you got to push up on it, right? That's an upward acceleration. Okay, does that make sense? You're going down in an elevator. It's slowing down as it reaches the first floor. Okay, that's all it is. What's the velocity at the end of the acceleration and how far has it traveled, right? We're going to say VI for number 3 is 4.00 meters per second. Actually, we're going to make it -4 because it's downwards. There's an acceleration of positive 2.00 meters per second squared because it's upward. Hey, why is it not -9.81? Because there's something other than gravity acting here, right? There's the cable in the elevator. It's pulling it upwards to cause it to slow down. The time is 1.80 seconds. We're looking for VF, the velocity at the end of it, and we're looking for the displacement there. For VF, I think I'm going to just say A is equal to delta V over delta T. I'm going to rearrange it to solve for delta V. Take the T up by multiplying. And let's solve for delta V there. Delta V is 2 times 1.8, which is 3.6. Now, delta V is also equal to VF minus VI. We're looking for VF. Take the VI over by adding. It becomes delta V plus VI. In other words, it's 3.6 plus -4, which gives me a final velocity of -0.40 meters per second, or 0.40 meters per second downward. Is that okay? Steph, is that okay? Did you get question number 3? No? And finally, we're looking for the displacement. We got a couple options here for the displacement. Let's use d is equal to VIT plus 1 FET squared. We got VI, -4. Don't forget the negative, though. T is 1.8 plus 1/2 of 2. Again, it's not -9.81 because it's something other than gravity acting. 1.8 squared. All right, so let's do this here on the calculator. Let's say -4 times 1.8. That's the first term. Let's add to that brackets 0.5 times 2 times 1.8 squared. And that bracket, we end up getting -3.96. Right? You guys can do this, right? You guys can do this. I think we've been at this for 2.5 weeks now. Look at where you guys are compared to the first day. Like, seriously. In 2.5 weeks, okay? 2.5 weeks ago, I was walking toward the back of the room 5 steps, and then 2 steps further, and I asked you to tell me how far I went. Seriously. And now we're solving problems like this, right? And for the most part, getting it. Imagine where we'll be at the end of the year. Holy cow.